Hi guys, after we studied the systems of numbers or the set of numbers, now we are going to explain why the real numbers are so important. The real numbers has no gaps. That means in mathematics we called it completeness of property. Completeness, I guess my spelling is right, property. What do we mean by completeness of property? Completeness of property means that the line of a real numbers has no gaps. We always say that the 0 and this 1, this is 3, and so on till infinity. Minus 1, minus 2, minus 3 till minus. So we go into the minus infinity from this side and to the plus infinity from this side. So we usually say that, or in fact, the real numbers has no gaps. Why? Uh, we call, let me here explain. If we, this is the real numbers, this is the quotient numbers, okay? If we plot the rational numbers, they look the same line, but it's not. Why? Because this has gaps. For example, the squared, where's the 2? I forgot the 2. See here, for example, the square root of 2, which is located here, is missing, is not in a Q. It doesn't belong to the rational numbers. And same thing, if I have here 4, and same thing for the 5, I guess, yeah. For square root of 3, I think square root of 3 is here in the middle, not square root of 4. Ouch! Square root of 3 is also here because it is less than 3, and so on. So we have a distribution of numbers which is called the rational numbers, which is located in R, okay? And they are not located in a Q. So Q has gaps. These gaps are made from the rational numbers. If we fill these gaps in the quotient number by making the union, like a Q union, the rational union with the irrational numbers, the result will be the real numbers. Okay? So now we have the another property. Completeness of property. First, that means R has no gaps. Actually, we have a certain names in mathematics, but it's not appropriate to say it in calculus. In calculus, I need you just to know the fact. This completeness of property, when you study like advanced mathematics, for example, when we study introduction or principles of mathematical analysis, you will find a lot of theories talking about or talking about the completeness of property and the effect or the effects that are made from the completeness of property. The second fact, which is very important, between every two real numbers, there is, or there are actually, but let me say here, there is uh, an irrational number. Stop. No matter close, no matter how those numbers are close. are close, actually not close. So in the real numbers, between every two real numbers, even if they are very, 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 very close, there is an rational number between them. Okay? So when we say between every real numbers, there is irrational numbers, that means those real numbers could be irrationals or could be rationals. In general, between every two irrational numbers, we have between same thing between any two rational numbers there is an irrational number, and between any real numbers in general there is a rational number, and between any irrational numbers, two irrational numbers, there is. So we're going to say this with the same words. So equal every two, for example, let's say here irrational, between every two irrational numbers there is an rational. Let me close my phone. There is rational, okay, no matter how, why do I miss letters, how those numbers are close. And third or fourth, we can say that between any two real numbers, for all x and y belongs to R, there is, let's say we call it sometimes a Q, for all x, y, and R, for any two real numbers, there is Q belongs to the irrational numbers, such that I'm going to write the such that like st, such that x, for example, actually I need to put another term just to be accurate. Okay, and can I write it? Actually, it's not here. Okay, I have to put it here. I have to put like y should be greater than x. Okay, the opposite is right too, but we have to mention they are not equal. Okay, so we're going to put like, so q between y. Okay, so the main thing that we need to say, because it's important for the next lectures and for the next concepts, that between any two real numbers there is infinity real numbers. That's the secret of the uncountable set. The natural numbers and the integers and the quotient numbers, or the rational or rational numbers, are all countable. It's not our subject to talk about countable and uncountable sets, but it's countable. But the real numbers are not countable. Why? Because we say that the, like say, the number of numbers, the amount of numbers in the real line we can say that it's the same the real numbers that contains in the interval between 0 and 1, and we're going to talk about what do we mean by interval just in the next lecture. Okay, so the amount of numbers here, which is infinite, almost or exactly the same numbers that existed on all the real numbers. Okay, it's gonna cause you a headache a little bit, but you need just to accept it for now, and then with the study you're going to understand it or fully understand it. So we call it the like uncountable numbers, infinite uncountable numbers. So the real number is very important because it has no gaps, and between any two real numbers there is infinite of real numbers, no matter how close those numbers. Okay, so these are very important facts. Okay, so in the next lecture we're going to talk about about the intervals. What do we mean by sets and what do we mean by intervals? In the natural numbers, we usually take like a subsets of natural numbers. Subsets like A contains like 1, 2, 3, or a certain amount of numbers, and we call it just a subset of natural numbers. And same thing with integers. We can say, for example, that B is the set of X, such that the X equal to, for example, minus 10 to plus 20, for example, and we have to say that, you forget things, X belongs to the integers. So this is just an infinite, and it has the 1 and the 2 for this set like A. It contains the 1 and the 2 and the 3 and so on. Okay, infinite, but it doesn't know anything about the numbers between 1 and 2. And the same thing for this set. It contains maybe the minus 1, and it contains like the minus 9, the minus 8 till 0, and then 1, 2, 2 till 20. But it doesn't know anything about the numbers between like 0 and 1, or between like 3 and 4. Okay, it contains the 3 and it contains the 4, but it doesn't know anything about the numbers between 3 and 4. So this relation, or this concept of the numbers between any two numbers, it actually should be like fractions, okay, which contains decimals. For example, the numbers between 0 and 1 should be all decimal numbers that less or equal than 1. So now I'm going to like define the concept of intervals.